Today we will be doing a lab to determine the relationship between the net force on an object and its acceleration. The equipment that we'll be using for this lab is the Vernier Go Direct cart, which hooks wirelessly to your Chromebook, some masses, a mass hanger, the Vernier Dynamics cart, a scale, and just this little box, plus your Chromebook. So to start out, what we need to do is we need to first find the mass of all of the parts in your experiment. So what we're going to do is we're going to take the hanging mass, all the little masses in your bin, and a cart. Take a scale, place this on the scale, zero the scale, then take all of your stuff, not the basket, but everything you're going to be using in the experiment, and put it inside the little bin and find the mass. You need to convert this mass to kilograms at the end, but this is what we call the total system mass. This is the mass of everything in our experiment. I'm not sure how clear this is going to come out because sometimes when you're recording a computer screen with a video camera, it flickers a little bit and the resolution isn't very good. But let's try. So to set up the Go Direct sensor cart, what we need to do is open up your Vernier Graphical Analysis and use this selection right here, which is Sensor Data Collection. So here's how the sensor works. This is what Bluetooth, and it will communicate with your Chromebook. So your Chromebook needs to have the Bluetooth sensor on. What you're going to do is you're going to turn the card on by hitting this button, and it should be blinking a red. The button here should be blinking red, or the light I should say. Now on your cart, you'll notice that there's a little code right here, ID 0V100205. That's the code for your cart. What you want to do is, since there'll be several people using these in the room, there'll be several codes listed here. Me, I only have one cart turned on, so my code comes up right here. It says cart G, that's a green one because we have green and yellow ones. Sometimes we do experiments that have two carts in them. That's why there's a green and a yellow. All right, so we want to connect our cart, not someone else's. Then when your cart shows up here, we're done. Now the program automatically defaults to two graphs, a position time graph and a velocity time graph. We're going to look for accelerations, so what we actually want to do is we want the velocity time graph. So if you come over here, we hit our graph tools, and we go to one graph. So now we have just one graph. And now we want to change this to velocity. Turn on velocity, turn off position. Now that we have just a velocity time graph, we're ready to take our data. All right, now that you have the Chromebook set up to collect velocity time data with the sensor cart, what we need to do is run several trials of the experiment. So each trial, what we'll be doing is we'll be changing the amount of mass on this hanger. Then this hanger goes over the pulley and it causes the cart to accelerate. So we want to start out with 20 grams. The hanger is 5 grams. So you put 5 more grams on the hanger. All right. And that gives us 10 grams. This 5 never gets removed from the hanger. Secondly, we take another 10 gram and put it on there. So now we have 20 grams on the hanger. All of the masses that are not being used, you want to take these and just place them on top of the cart. Now with me working alone, it's a little less efficient. But what you're going to want to do is have one person operating the computer, one person releasing the cart, and maybe one person working on the other end with the pulley, making sure that the hanging mass has the proper mass on it and that it's properly put over top of the pulley. All right, so to start collecting our data, all we do is we hit collect, let it go, and we're done with one trial. Now that we have a trial, we want to highlight a section of data. There's our nice velocity time graph. And we should know by now that the slope of the velocity time graph gives us the acceleration of the object. So let's find the slope of this by doing a linear curve fit. So if I go down to my graph options, I can do apply curve fit, linear, very nice curve fit. I read my slope in the box here. It says 0.5204. So the acceleration of my cart was 0.5204. So you can enter that into your data table. Now I want to do another trial. So I want to increment my masses by 10 grams each time. So we have enough mass here to actually go up to 110 grams total. So to increment my mass, I'm going to get the pulley. So there's 10 grams on here right now. So there's the 5 for the hanger, the 5 that we keep on there, and the 10. That makes 20. So if I take the 10 off, I want to put that back on the cart because all the masses that I'm not using, I want to keep on the cart so that I don't change the total mass of the system. Now I put a 20 on. So I have 5 plus 5 is 10 plus 20. Now I'm at 30. So I do the same thing again. Place the string over the pulley, hit collect. I can find the slope of my velocity time graph again, and that will give me a new acceleration. So what I do is we just keep incrementing the masses until we get up to a total hanging mass of 20. So here's what we can do again. So now that I have this on there, the 20, I can take the 20 off. So this was a total of 30. So I can, oh, actually I don't have to do that. So I have 30 on there. Now I can put the 10 on, and that gives me 40. All right, so we just keep incrementing, going up by tens and measuring our acceleration. When you have the total amount of mass on there, you should have about 110 grams, and then we're done, and we do our data analysis. Now, one thing to be careful of is, one, make sure when you put the cart on the track that it's not out of the grooves or something like that. It should be rolling nice and freely. All right, so when it hits this end, a lot of times it moves off the track. So just make sure it's reset on the track nicely, all right, before you do another trial. And secondly, when you graph your data, or actually the computer, the data is graphed already right here, but when you analyze your curve fit, make sure that you pick data, all right, by highlighting it, that's only on the nice straight line where the acceleration is constant. All right. So do your data analysis, and that concludes the instructions on how to do this lab.